Today we are going to talk about ideal voltage source and ideal current source. Voltage source. Voltage source is a device which provides voltage at its terminals. Voltage source. Voltage source is one in which the voltage is fixed but current changes. A dry cell, car battery and DC generator are DC voltage sources. Hydroelectric power plant. Mostly in hydroelectric power plant, turbine-based generators are used, which are nothing but AC voltage sources. Those AC generators produce alternating current. Similarly, in thermal power plant, nuclear power plants, AC generators are used, which act as a AC voltage sources. Even those in AC generators, alternating current is produced. Current source. A current source is a device in which current is not changing and current produced does not depend upon how much voltage produced at the terminals of the device. In short, current source is one in which the current is fixed but voltage changes. Now we are going to talk about ideal voltage source and ideal current source. Ideal voltage source, it is also called as constant voltage source. A voltage source whose terminal voltage always remains unchanged for all values of output current is known as ideal voltage source. Ideal voltage source is indicated by empty circle. Plus and minus symbols are written outside of the circle. But in American notation, plus and minus are written inside the circle. V nothing but constant terminal voltage. This symbol is nothing but symbol of ideal voltage source. Internal resistance of an ideal voltage source is 0. Now consider an ideal voltage source with terminal voltage of 50 volts. Now connect a resistor of R ohms across it. R is any value, whatever the value you connect. But terminal voltage will not change. The terminal voltage will remain same, always same, that is 50 volts. In such conditions, the given voltage source can be called as an ideal voltage source. Consider an ideal source of 50 volts. Now we connect a load resistance or R ohms across AB. Terminal voltage of ideal voltage source is 50 volts. Now R is the value of the load resistance. That can be any value. For any value of R, the voltage across the load resistance is also 50 volts. In such case, the given voltage source can be called as ideal voltage source. Consider one example. Now, load resistance of 30 ohms is connected. The terminal voltage is equals to 50 volts. Now, if load resistance is equals to 40 ohms, we find that terminal voltage is not changing. It remains the same of 50 volts. Now 60 ohms load resistance. Terminal voltage is equals to 50 volts. When the load resistance of 30 ohms, current flowing through the circuit is equals to 1.66 amperes and terminal voltage equals to 50 volts. Now, when 40 ohms load resistance is connected, then also we find the current flowing through the circuit is changing, but terminal voltage is not changing. Once again, for the load resistance of 40 ohms connected, terminal voltage is not changing. No doubt the current is changing. Now current flowing through the circuit equals to 1.25 amperes. And for 60 ohms as a load resistance, the current flowing through the circuit equals to 0.833 amperes. Here also we do find terminal voltage of the battery or terminal voltage of the given cell is not changing. Thus, for the load resistance of 30 ohms, 40 ohms and 60 ohms, the current flowing through the circuit is changing, but the terminal voltage of the given device or source is not changing. In such case, the given device is called as an ideal voltage source. Thus, whatever the value of the load resistance, the terminal voltage of the given device not changing. In such case, the given device can be called as ideal voltage source. In ideal voltage source, the current flowing through the circuit changes, but the terminal voltage does not change, whatever may be the value of the load resistance. Ideal current source. It is also called as a constant current source. A current source which delivers constant amount of output current. Output voltage changes not depending upon load resistance connected across its terminals is called as ideal current source. Internal resistance of ideal current source is infinite. Ideal current source is indicated by an arrow inside an empty circle where I equals to constant current. Diagram showing constant current source of 10 amperes. Diagram showing the constant current source of 2 amperes. A practical current source has a shunt resistance and a resistor across whom we want to measure the amount of current flowing. But in ideal current source, the value of shunt resistance is infinity. Therefore, no current is flowing through the shunt resistance and all the current is flowing through the load resistance. Hence, the current through load resistance always remains constant irrespective of voltage across the load resistance. A load resistance of 30 ohms is connected across the given device. The current flowing through the circuit is found to be 10 amperes. Now a load resistance of 40 ohms is present in the circuit and the current flowing through the circuit not changed and it is remaining 10 amperes. That means amount of current delivered by the current source is 10 amperes. Thus, in ideal current source, the value of the current remains the same and not depends upon the load resistance connected across its terminals.